In this video, we are going to talk about trigonometry, which is the study of the relationship between the sides and angles of triangles, and that conceptualization can be extended further into circles and other shapes, and they can tell us a lot about the real world. And it was first discovered, or at least written down, in geometrical representation around the 3rd century BC, specifically in Euclid's Elements, which pops up all the time in mathematics. And then Archimedes also wrote about trigonometry using geometrical representations. But it wasn't until the 150 BC when Hipparchus came along and wrote on a clay tablet the first table of trigonometric ratios. And so we had the first evidence of algebraic notation of trig. And then in 1200 AD, finally we had a robust system, and trigonometry became a field of itself, and the study of trigonometry was born. And we still use his framework, his standardized practice today in trigonometry. And so what is trigonometry? I defined it for us already, but more specifically, we can get into trig ratios, which you probably have already memorized using SOHCAHTOA, the mnemonic SOHCAHTOA. And we have these functions called sine, cosine, and tangent to tell us a relationship with a circle. And so you can see cosine of theta. If we know the angle, we know cosine, which is on the x-axis. And then sine tells us the y-axis. And we can actually rotate this right triangle all the way around the circle until we hit 360 degrees. And then we can go further. We can go to 400 degrees, 700 degrees. And we can keep going and going and going. This is actually quite valuable, especially when you're dealing with time or rotation in physics. And so I actually have a cool animation from Math is Fun, which you can see here. So you can see this right triangle can be rotated all the way around, and it tells us some relationship about the trig identities, the trig functions, which results in trig identities. And we started here in our picture, and then we can see we can keep going. And it produces this graph, this graphical representation of the sine and cosine functions. And tangent looks much different, and cosecant and secant graphs look much different than this. But for our purposes, we will focus on cosine and sine. And so you can see those here in this graph right here. And so it makes sense, right? Sine is the y-axis. So when x is equal to pi, which is, if we look at this circle, would be right here, we actually have the value output of the sine function would be 0. And that makes sense because we are on the x-axis. The y value is 0. And so, similar concept with, I don't know why this is lagging. What is going on? Hold on one second. It led to the trig identities. So additional relationships between all of these angles and sides of the triangle and the circle. And so, let's go through a great way, and I mean a great way, to remember all of the trig identities. So not all of them, but most of them, and some of the most important ones. So let's do that. Okay, so the method for remembering trig identities is drawing a hexagon, which I have drawn here. And we label each vertex of the hexagon with one of the trig functions. And then we place a 1 in the center. Now, order does matter when placing these functions. And so the way to remember it is you start with tisk, so tangent, sine, cosine, so tisk, and then cotangent, cosine, and cosecant we can remember on the right side. All cos are on the right side, and CO are next to each other, and then we have cosecant, and then that just leaves one remaining function, which is secant. Excuse me. Sorry. Excuse me, sorry. And so we have secant. Now that we know our 6 functions, and we have our hexagon labeled with a 1 in the center, we can start identifying each relationship and the trig identity associated with that relationship. So the first one we'll say is quotient identities. So if you know your quotient identities, you will know them even better now. And so the way to remember the quotient identities is to draw this arrow, and we can draw tangent all the way to cosine. And so tangent of x, or tangent of theta, is equal to sine of x over cosine of x. And then we can keep extending this. Imagine we wanted to find sine, the quotient identity for sine. Sine of x equals cosine of x over cotangent of x. And this is our quotient property. And we can extend this all the way around the hexagon, which is awesome, right? That's so easy to remember. All we had to remember really is our hexagon. And then from there, we can get all of our quotient identities. But that's cool. Now let's do product identities. Let's erase this. Now let's do product identities. Product identities, and we can draw these. We can draw arrows like this pointing to each other to remember our trig identities. And so if we draw cosecant to cotangent, we find that cosine of x times cosecant of x, cosine of x times cosecant of x, in fact, equals cotangent of x. And we can apply this everywhere, right? We could do cosecant times tangent, and we get our product identity. And so this is another fascinating use of the diagram, but we can go even further. We can know our reciprocal identities. Our reciprocal identities, which are just a down arrow, or just one arrow to remember it. So the reciprocal of sine of x. Shoot, you're not going to be able to see the blue with the blue background, are you? Purple. The reciprocal of sine of x is 1, because we went through the 1, over cosecant of x. So the reciprocal of sine of x equals 1, we went through the 1, over cosecant of x. And we can do this for everything. Let me make some space again. My gosh. Delete. Where were we? On the reciprocal identities. And so if we wanted to find the reciprocal of tangent of x, we know that it is tangent of x, the reciprocal, equals 1 over cotangent of x. So easy, so simple. Just because of this diagram, we will be able to know all our identities. I love it. Another set of identities are the cofunction identities. Cofunction identities. And these, we will draw a side arrow. Just like that. Cofunction identities are side arrows. So the cofunction for sine of x is equal to cosine of 90 degrees minus x degrees. And to make this more concrete, secant of x, the cofunction for secant of x, is going to be equal to cosecant 90 degrees minus x degrees. There you have cofunction identities, but I would also want to emphasize that you do not include 1 when you go from tangent to cotangent. So hopefully that does not trip you up. And so let's make some more space here, because we can keep going. We can keep going. We have the invaluable Pythagorean identities. The Pythagorean identities. The Pythagorean identities. And for these, we want to draw like a curvy arrow, just like this, in 3 spots. Just like this. That's how we will remember it. So, the trig identity is sine squared cosine squared equals 1. You probably know that off the top of your head, but here is how we would use it visually to remember all of them. So sine squared of x plus cosine squared of x equals 1. And we remember how to derive this too, right? We had x squared plus y squared equals r squared, and then we divide by r squared, and we get 1 on this side of the equation, and then we get these squared trig functions of sine and cosine. And so we can apply this to tangent, our trig Pythagorean identity to tangent. So tangent squared plus 1 is equal to secant squared. Boom, you thought you would never be able to memorize that, but you just did. Very easily, very simply. And we can extend it once further. We get 1 plus cotangent squared of x is equal to cosecant squared of x. And you are done. Boom, we just, in one simple diagram, we were able to go through 6 or 5 different identities. We went through 5 different trig identities. And of course, you know about the inverse to find the angle. So imagine we knew cosine and cotangent, but we didn't know the angle theta. We can use the inverse trig functions, such as, I can't write with the mouse, such as tangent of theta. Just like that. We could use calculators or whatever. And so we know the sides, but we don't know the angle. But now we know the angle. And that's called the inverse. Inverse trig function. And so there we go. That is really the trigonometry in a nutshell. And with that, we'll see you in the next video.